Alright, so this is the second part of the twin, and forgive me if I ain't 100% on this. It's going to be kind of rough. Using reference angles and the 30, 60, 90 pattern, evaluate the secant of negative 300 degrees. Alright, let's get my bearings right here. Now, a negative angle is going to start like all angles do, which is on the positive x-axis, and then we're going to rotate clockwise. Now, that's about 300 degrees of negative rotation. Now, what we're missing here is the reference angle. There was 60 degrees of rotation left. So, 60 degrees. And, you know, that's something I could have done from the beginning. I could have gone to that, and I could have done 360, and I could have thought secant of 60 degrees. I'm not my usual self today. And that would have sped things up quite a bit. So, we have ourselves a 60-degree reference angle, and then we can apply 30, 60, 90 theorem. So opposite of a 30-degree angle is a 1, opposite of a 60-degree angle is a side length of root 3, hypotenuse is 2. So root 3, it's rising, that's positive, adjacent's a 1, hypotenuse is 2. And the secant ratio is the funny guy. You know, it's the reciprocal of cosine, it's ha. So hypotenuse over adjacent, so 2 over 1, which is just 2. Now, a lot of time was wasted drawing a triangle, to be quite honest with you. A whole lot of time was wasted. What you could have done is this, and if you've done a circle for this quiz, you can go to 60 degrees. You'll be right here. You'll be at 1/2, comma, root 3 over 2. That's 60 degrees. And on your circle quizzes, the cosine of an angle is going to be x over r. On the unit circle, the radius is 1, so it's just x. Now, the reason I'm talking about cosine is because cosine is the reciprocal of secant. So this would have told me that the cosine of theta is 1/2, which means that the secant of the same angle is 2. So, you know, be thinking about your circles, kids. Just be thinking about your circles. All right? Now we're on 15. And here's my one issue with this new board is that I can't show things in a calculator with it. It is my one issue. I haven't figured out how to do it yet. It doesn't look like I can. It looks like I'd have to switch over to a screen record, break the video, restart, maybe do some merging, which is just something I really don't have enough time for right now. Nor do I have the patience for it. But anyways, you're supposed to find the measures of angles A and B. So, I don't know if this will show up on that white there. Yeah, okay, so not there, it doesn't. The 13's relationship to angle, and I'm going to start with angle A over here. 13 is opposite of angle A, and 18 is adjacent to angle A. So, when I'm talking about angle A, I know that the tangent of angle A is going to be 13/18. Now, most kids got this question right on their last quiz. You really did. It was a pretty good one as far as that quiz went, which means that the measure of angle A is the inverse tangent, the arc tangent, the angular tangent of 13/18. And it'd be cool if you guys saw what I was doing on my laptop, but you won't. At least I don't think you will. It would be really cool. Alright, I'm in degree mode. Right now I'm just pushing buttons on TI-84. Arc tangent, 13/18. Now the good news is if you paid along in class, you know where this stuff's at. It's about 35.84 degrees. Alright, now switching over to angle B. Relationships change when you look at angle B. This is now the adjacent length, and this is now the opposite length. So the tangent, need a different color. The tangent of angle B is going to be 18/13, which means that the measure of angle B is the arc tangent of 18/13. And you could also do 90 minus in a calculator and just get it. It wouldn't be too hard to do. So arctangent 18/13. Hopefully it's something like 54.17, 54.16. It's about 54.16 degrees. All right. Moving on to the next one. Evaluate the arctangent of negative 2.1 such that the angle lies between 0 and 180 degrees. Now, I know that my answer has to be in either quadrants 1 or 2, because it's between 0 and 180. I know that this is negative. So, remember your little acronym here, ASTC, all schools torture children. And I'm going to be in quadrants 1 or 2, but this is negative. That's going to be in this quadrant. The angle that I actually want is going to look something like this. Okay, this is the actual angle. So I'm going to go to my TI-84 and I'm going to type arctangent negative 2.1. And it's going to give me something. It's going to say negative 64.54 degrees. Negative 64.54. So, which is oddly enough an angle that exists in quadrant 4. Which doesn't satisfy the requirements. Requirements were this thing be between 0 and 180 degrees, and that's obviously not it. But what it is a reference angle. So here, I get to just copy that down as a reference angle. Now, the actual angle is going to be the straight angle of 180 minus that. So theta is 180 degrees minus 64.54 degrees, which is going to be 115.46. I'm pretty tired. Be double checking my math. All right, 17. Evaluate the arc cosine such that, arc cosine of negative root 2 over 2 such that the angle lies between 0 pi and 2 pi. And we'll do this two approaches. We'll do a circular approach and we'll do a triangular approach. All right, so my number right here, it is negative. All right, that's a big deal. Go ahead and do a quadrant here. This is the classic approach, which is probably the highest level of understanding. The circle is wonderful, but when you do the circle, you're not applying certain ideas. There's less going on. That's why it's easier. But cosine is the x-axis, okay? It's negative here and here. Sine and cosecant are positive. Tangent and cotangent are positive. Everything else is negative. Now, if I go push buttons in a TI-84, it's going to tell me negative 45 degrees. So I'm doing arc cosine negative root 2 over 2 in a TI-84. Oh, sorry, it told me 135. Boy, I'm off. And I know that. You can tell I'm off. So by TI-84, the arc cosine of negative root 2 over 2 is equal to 135 degrees. So that's going to look about like that. And that is one of them. One of your answers is 135 degrees. What you're going to have to do is pi rads, okay? Now, what matters here is the reference angle. The reference angle is 45 degrees. It takes 45 degrees to get to the x-axis. So we're going to draw that reference angle in the other quadrant where the angle exists, and then we're going to think about rotation again. So that angle is going to be the semicircle or the straight angle of 180 plus 45. Theta 2 is going to be 135 plus 45. Sorry, 180 plus 45, which is 225 degrees. So again, my two answers here were theta 1 being 135 degrees, theta 2 being 225 degrees. Now 135 degrees as a pi rad is 3 pi over 4. And 225 degrees as a pi rad should be 5 pi over 4. So there's your two answers, 3 pi over 4 and 5 pi over 4. Now, this was the longest way possible doing this. It's probably the highest level of understanding. I mean, the kid can draw angles. They can understand concepts of reference angles. There's just such a deep understanding of what's going on here that this is the highest level way of doing that problem as far as I'm concerned. Because the other way is really easy. The other way is you know the unit circle, which does require memorization, no doubt. Now, the question was originally asking what angles have a cosine ratio of negative root 2 over 2, which means on the unit circle, where do I see negative root 2 over 2? And I see them right here and I see them right here. I see negative root 2 over 2, positive root 2 over 2, and then I see down here negative root 2 over 2, also negative root 2 over 2. Now on the unit circle, cosine is x. I drew that one up there where you couldn't see it, didn't I? Okay, that's the issue. I gotta figure this out, right? On the unit circle, cosine is x. You just have to remember that. I'm going to write it down for you. All right, so the cosine of an angle is the x-coordinate. So I would have seen here, I would have seen my 135 degrees, which would have been 3 pi over 4. And I would have seen 225 degrees, which would have been 5 pi over 4. So a circular approach is quick, man. It's quick. It took me longer to draw it and explain it. But the reality is if I'd have had that unit circle in front of me, I'd have been done in just a few seconds. All right, find two solutions to the equation 2 cosines of 3 beta plus 1 over the interval from 0 pi to 2 pi, such that beta is an angle that lies between 0 pi and 2 pi. Now, this is to get all the answers is kind of hard because you got to know quite a few things, and you guys are just in Algebra 2. We'll talk about that in just a minute. Let's go ahead and do the work on the equation here. All right, so the first thing we're going to do is the easy stuff. We're going to subtract the 1 from both sides. And my Greek betas are going to be pretty bad. So that equals negative 1. I got a little off there. Let's redo that for you. So I subtracted 1 from both sides. Now I'm going to divide both sides by 2. And to find 3 beta, I'm going to do the arc cosine. I'm going to do the opposite actions. I'm going to take the arc cosine of both sides. So the arc cosine of the cosine of 3 betas is the arc cosine of negative 1/2. The arc cosine and cosine, they annihilate each other. And what this tells me is that 3 beta is going to be the arc cosine of negative 1/2. Now, arc cosine of negative 1/2, and I'm thinking about circles here, okay? I'm not wanting to spend a whole lot of time on triangles. I know that right here and right here I have negative 1/2. So I have negative 1/2 root 3 over 2, and I have negative 1/2 negative root 3 over 2. And that happened at 120 degrees, and that happened at 240 degrees. That's where that happened. So 3 beta is going to be 120 degrees or 240 degrees. Now this is how you get 2 of the answers. You'll notice it says find 2 solutions, and you get extra credit if you can find all of them. And there's 6 of them on this particular one. So the next step's pretty easy. If 3 beta is 120 degrees, then beta is going to be 40 degrees because we're going to divide by 3. If 3 beta is 240 degrees, then beta is going to be 240 over 3, which is 80 degrees. There's two of your answers, okay? Now, we do want these in radians, so we're going to have to do some conversion at some point in time because it talks about 0 pi to 2 pi, so I'm going to have radian answers, but that's not a big deal. I'll worry about that later. All right, the fun part. This is the cosine function. We did a graphing section. We did. Normally, cosine has a period of 2 pi. So normally we have a period of 2 pi. This function is 2 pi over b, and b is 3. 2 pi over 3. So normally we have a period of 2 pi, which is 360 degrees. This one has a period of 2 pi over 3, which is 120 degrees. Now, I am allowed to return answers so long as they're between 0 and 360 degrees. So if I have a period of 120, I can add 120, and it'll still be good. That's 160. And I'm going all the way out to 2 pi, right? And I can add another 120, and I would be 280. Now I can't add 120 again because that would take me out to 400 degrees, which is above 360. Okay, so that'll make this B4. Beta 5 is going to be 80 plus 120, which is 200 degrees. And beta 6 is going to be 320 degrees. So that's what they all are as angles. You just have to add this period. Period is the cyclic, the repetition, which we did talk about. All right, so moving forward, I do want pi rads. It's kind of a bear for some, but it's really not that bad. You take your 40, you throw it over 180, and you include pi. Zeros cancel, 2 pi over 9. That's beta 1. Beta 2 would be 16 over 18, which is 8 over 9. It seems too high. 16 over 18 divided by 2. Yeah, 8 over 9. 8 pi over 9. Beta 3 would be 28 over 18. That's 14 over 9. Don't forget about pi. All right, over here, beta 4, we got 80 degrees. That one's kind of hard to see on your end. That's going to be 80 over 18, which is 4 over 9, 4 pi over 9. Then we got 200, that's 20 over 18, which is 10 pi over 9. Then we got 320, which is 32 over 18, that's 16 over 9. 16 pi over 9. So there's that one, and it was one of the tougher ones on here. It really was, and you get full credit if you can give me 2, and if this was a pre-calc class, I'd make you give me all 6, but not. You're in Algebra 2, and it's the end of the year, right? So just happy if we can get what we can get. All right, next up we got a graphing problem. Hopefully this won't be too bad. I don't know, we'll find out. We shall see, right? Of course, I know it's at the end of the year, and I know that means that performance goes down pretty hardcore because truth is you don't want to be here. That's the honest truth. Some kids still like to try, though. All right, so first off, I'm going to think about mom. Mom is y equals the sine of x. Our lowest value is -1, probably the highest value is 1. This comes from just knowing unit circle in general. The 5-point technique that I taught you is to go from 0 pi to 2 pi. Halfway between is pi, halfway between is pi over 2, and halfway between is 3 pi over 2. And mom starts at the origin and then rises. So that's mom. Okay, now let's go look at our function. Our function right here. We have the -2. This is the midline at y equals -2, or fall 2. Okay. The 2 is the amplitude, and the negative symbol, which I kind of missed there, is a reflection. So a lot of things are going to happen. Now, there's also something else here. It's this guy right here. Your period is normally 2 pi, but here it's 2 pi over 4. Whoops, can't see any of that. Normally it's 2 pi, but here it's 2 pi over b, 2 pi over 4, which is pi over 2. All right, time to graph that thing. We're still going to start at 0 pi. We're going to stop at pi over 2. Halfway between 0 and a half is a quarter. Halfway between 0 and a quarter is an eighth. And halfway between a quarter and a half is 3/8. If you don't believe me, do 0 plus 1/4, press enter, then divide it by 2, and so forth, because you're finding middles, you're finding averages. Now, the midline is to fall 2. Here's the midline. This is what I'm going to rise above and fall below on. And your amplitude is 2. So you're going to have to go down 2 above that and up 2 above that. Kind of fun stuff. But since your amplitude is 2, you're going to have to go down 2. Now, normally, mom starts by rising out of the origin. This one, however, has a reflection. Okay, so we're reflected. And the origin got shifted down to the midline too. So you're going to start at your midline and you're going to fall 2. And once you've fallen as far as you can fall, you begin to rise. And then you rise until you've risen as far as you can rise, and then you fall. And there you go. There's that graph. I don't think it's too bad, but then again, I've done them for a long, long time. You just have to know things, right? That's all. You just have to know things. All right, moving on to the cosine function. It's our next one in here. We're almost done with this twin. So we have another mom. We got to talk about cosine. Y equals cosine of x. Same key points as sine because it has the same period. The period is 2 pi. Halfway between 0 pi and 2 pi is pi. Get that out of your way. Pi over 2, 3 pi over 2. Now, still have an amplitude of 1. Cosine, however, starts high and then falls. They're actually the same exact function, except cosine has a horizontal shift done. If you horizontally shift left pi over 2, you'd see the same graph. So they're very, very similar graphs. That's why we call this section sinusoidal, because they're basically just graphs of sine functions. That's all they really are. So let's take a look at what we got here. We have a 3 for the cosine. That's my amplitude. All right, we're looking inside this 3 pi over this pi over 4 theta. Your period is going to be 2 pi divided by the b term, which is pi over 4. And the pi's cancel, and you're left with 2 over 4, which is a half. So that's kind of cool. Then we have our plus 1, and this is your midline. It's y equals 1. So let's take everything we have and let's just start graphing. We're going to start at 0. We're going to stop at 1/2. We're just going to do a single cycle. Halfway between 0 and a half is a quarter. Halfway between 0 and a quarter is an eighth. And halfway between a quarter and a half is 3/8. You'd be surprised the kids that get fractions like this are the kids who have, fixed things with wrenches, because wrenches literally teach you fractions. The midline is at plus 1. And our amplitude was 3, so I'm going to have to rise 1, 2, 3 above. I'm also going to have to fall 3 below. So that's there too. So 1, 2, 3 of the midline. Now, cosine starts high. And this one was not reflected. It has a positive 3 out there. So we're going to start 3 above the midline. and then we're going to fall. Then we're going to fall 3 more, and once we have fallen as far as we can fall, we just begin to rise. That is one cycle of that particular cosine function. Easy peasy, lemon squeezy. Like, it's not hard. You can do this. All right, last question is twin. It gets its own page. I would say it gets its own page because it's hard, but it just gets its own page because that's just the way it worked out. Hopefully you guys like the new board. Hopefully it makes things a little easier for y'all to understand. I think it looks cooler. It's a little harder to use. All right, solve the trig equation 2 sine squared minus 3 sine theta plus 1 equals 0 over the interval from 0 to 2 pi. So, you know, the issue you got with this one is factoring, to be quite honest with you. And I can write things like this, and maybe you get it, maybe you don't, but I'm going to, just to help y'all, I'm going to think of this as 2x squared minus 3x plus 1 equals 0. And that's easier to factor for kids who are just, you know, accustomed to there being x's. But to create a 2x squared, it's going to take a 2x and an x. And that'll get you your 2x squared. To create a positive 1, it's either going to take a positive 1 or a negative 1 in both spots. They're both going to be negative because the outside has to make negative 2x, the inside has to make negative 1x to sum to negative 3x. Now, we're going to go back and replace what we did. What I actually did was I let x be sine of x. It's called substitution. So this becomes 2 sines of theta minus 1 times the sine of theta minus 1 again. And it's equal to 0. And now we can do something that we haven't done in a long time. It's called the zero product property. Remember her? Where's she been? She's been gone for a minute. The funny thing about factoring and zero product properties, they just never go away. Like, they always show up at some point in time. But by zero product property, 2 sines of theta minus 1 is a 0, or the sine of theta minus 1 is a 0. Now, let's see here. I want all answers from 0 to 2 pi. Boy, I missed that big. There we go. Those are the answers I want. Divide out the 2 and the sine of theta. We're doing easy stuff. Sorry, so add 1 to both sides. 2 sines of theta is 1. Then divide out the 2. The sine of theta is 1/2. All right, or the other side, the sine of theta is simply a 1 because you can add 1 to both sides. Now, I'm going to do these from a circular approach. I'm just going to think about unit circle. All right. So on the unit circle, this is going to be the y coordinate. Because it's sine, psi, y. We've been over that. So where is the y coordinate 1/2 on the unit circle? It's 2 particular spots, should be 60 and 120. And we'll all convert to radians in a little bit, but 60 degrees and 120 degrees. That gives me those guys. Now over here, where is the y coordinate 1? That happens at 90 degrees. There's your 3 answers from the circle. All right, now let's go ahead and do the conversion into pi rads. 60 degrees is pi over 3. 90 degrees is pi over 2. And 120 degrees is going to be 2 pi over 3. And there are your 3 answers. I hope you're good. This quiz is going to be Thursday.